Let's look at a couple more examples. I'll leave a couple of these for you to try on your own, such as this example 4. Sorry, these are not numbered, but let's look at example 4 and example 5. Now, this one, the antiderivative of the natural log of x divided by x with respect to x, is definitely a tricky one if you're not really sure what to look for. Because the first question is, well, if I'm trying to do U substitution, what is U going to be? So again, we kind of have some options. Well, U could be 1 divided by x, or U could be ln of x. Because what we know about 1 divided by x is the antiderivative is the natural log. But the issue with that thinking is that we want our derivative to match up with something in here, not the antiderivative. So actually, in this case, it actually makes sense to let U be equal to the natural log of x, because we know the derivative of the natural log of x is 1 over x times dx. And again, remember, du dx, I could write it as du divided by dx is equal to 1 over x, but we always just move the dx to the other side. Or this is also can be considered as differentiating implicitly. I'm just taking derivative of u, and that's going to be a derivative with respect to x of those particular variables. And again, why is this nice? Well, I could reorganize my integral here by writing as the natural log of x times 1 over x dx. Again, that's just another thing for algebra. If I have something in the numerator, I could pull that apart and do the numerator multiplied by 1 over the denominator. This is exact. This is equal. And this would give me u times du. So essentially what I have here is the antiderivative of u times du, because all of this is what I figured out to be du based on my original choice of substitution, which was u being ln x. And this is an easy integral, right? Because the antiderivative of u is just u squared over 2 by the power rule, and as always plus c. And then after I solve the antiderivative, I could go ahead and resub back in u, which is the natural log of x. So it has the natural log of x quantity squared over 2 plus c as my antiderivative. And it definitely takes some practice with figuring out u and finding du, but again, I recommend the same line of thinking when you're trying to solve integrals by U substitution is what's u gonna be, and then always solve du before you try to start working on it. Also, what will happen is you'll pick u and it won't really seem to work. I also recommend don't force it. Try a different u and see if that works more easily. And looking at one more, like this one to me would be really obvious because I have a 2x e x squared. And again, x squared and 2x, one of those is a derivative of the other. And since x squared is within the e, again, even though there's no parentheses here, if it's something in an exponent or either in the top or bottom of a fraction bar, anything within any mathematical grouping symbol, that's usually a big hint to say, okay, I'm going to let that be u. And since notice I also have the derivative of x squared within my integrand out front, basically I have e to the u times du. So this would all amount to e to the u du. And again, I could reorganize this 2x and dx over, but that's something that you'll notice that I kind of skipped that step because this all multiplied anyways. And then the antiderivative of e to the u is e to the u because it's the only function in math that maintains its antiderivative. It's the same as the original, same with its derivative, right? But again, I got to make sure to change everything in the integral to terms of u before I apply those rules, or else it will not work right. And last but not least, I want to resub in u, which was just equal to x squared. And so another, in a lot of these examples, you've been noticing that when I choose u, du is just magically part of my integrand. But most of the time, if we're trying to find the antiderivative or find the area under the curve or something like that, it's not going to be such a pretty situation where it's super easy and it just works out. And so the next question is, what happens if du doesn't appear as it appears above? And basically, there's some algebraic trickery we can do. There's some other stuff. And this is something we'll consider in the next couple of videos.